As you can see here, guys, again, last call, we've got our new table of contents. This is going to, again, be starting us off. We have, this will be the first page, right? 1 second. Make sure you guys can see me. Okay, so let's go ahead and move on now to our Go Blue. Again, make sure we get that table of contents situated. The Go Blue has 3 questions, guys. On the next page, page 2, number 1 states, what is the difference between weather and climate? Difference between weather and climate. Number 2 is what factors impact climate? What factors do we look at to know what's happening with climate, right? And then number 3, I believe, is what is the specific climate type of Florida and what causes it? So go ahead, take a moment to get those down. Get those down on page 2. And as for some important announcements, guys, no need to worry about notebook quiz since we already have notebook checks in this class. We'll have, super important, guys, the projects, the planet projects that we did a while ago, we started the research on, those are due on Monday. Those are due on Monday. So make sure we are getting ahead of that. We've got our research part of it, and then you put the research on your project. So it can be a brochure or poster, and just send me pictures of those with your names and handwriting. You'll be all set. And then for us, we do have the Unit 5 vocab that has been posted. Unit 5 vocab. Don't worry about the workbook stuff. That's for the in-person students. But you guys do need to take care of your online tests, part 1s and part 2. I believe maybe part 1 was due yesterday. Part 2 is due today. Make sure you finish those. Have those situated to optimize your grade. Okay. Let's go to keep things at a quick pace. Again, feel free to take pictures as we go along if you want to go slower than I'm going. Number 1, what is the difference between weather and climate? Again, if you have any answers, you can include them in the chat. But for number 1, let's actually go ahead and check out a video I have for that one. Weather versus climate. A lot of you guys, I think, may already know the answer to that, but let's go ahead and check it out nonetheless.
Climate and weather, weather and climate. What's the difference? Is there a difference? Yes, of course there is, otherwise I wouldn't be doing this video. I'm meteorologist Jason Myers, and unfortunately these two terms get incorrectly interchanged by a lot of people, including knucklehead senators like this guy.
It's a snowball, and that's just from outside here. So it's very, very cold out.
A snowball has nothing to do with... Never mind. Weather is not climate. Climate is not weather. The difference between these two terms is a matter of time. Weather is the condition of the atmosphere in the short term, from day to day. For instance, it snowed today. While climate is what we can expect from the atmosphere over a long period of time. It will snow at some point during the winter. More examples? Florida's a humid subtropical climate, and this is a hot, humid day in the Midwest. Phoenix is located in a desert climate. This is a dry heat in the plains. Climatologists study the climate. Meteorologists study the weather. They don't look much different. But why bother studying either? For more on that, check out our video.
All right. So again, as just stated, as we just heard, we think of them as the same thing, right? But what's the key difference? The key difference there is that climate. Oh, I just clicked on a link. Hold on 1 second. All right. The difference, guys, slow me out. The difference is the time, right? So weather, we're going to think short term. 1 second, guys. Exit out of this. So weather is going to be the short term, guys. Make sure to jot this down on page 2. Okay. Weather is the short term atmosphere conditions. So for that, I'm thinking of like, again, the hourly forecast, the weekly, the daily forecast, right? Whereas climate is going to be the long-term atmosphere conditions. So we're talking monthly, the seasons over the course of a year. So climate is long-term, weather is short-term. Weather changes, climate's pretty consistent, right? And then number 2, what factors are going to influence climate, right? What are things that meteorologists and climatologists are going to study to give us forecasts? Well, simply put, our main 2 are going to be temperature and precipitation. So how hot or cold it is on a daily basis, and also precipitation, which is the technical term for rainfall. How much rain are we getting throughout the year and in what times of the year, okay? Other factors might include latitude, Earth's tilt, topography, wind, and bodies of water. So for example, Florida, latitude, guys, is the distance from the equator. Okay, Florida has a low latitude, it's close to the equator. Topography, how flat or hilly a surface is. Again, Florida is very flat. It's the flattest state in the US. And again, Florida is surrounded by water, And lastly, if you guys didn't already hear in the video, number 3, what climate type is Florida? To be specific, it's going to be what we call humid subtropical. Again, surrounded by water, which is why it rains a lot. The air is very muggy. Muggy, not rugged, muggy. And again, we're also close to the equator, which is why it's very hot. Okay, so we'll put that, give you guys 10 seconds, get pictures, get that situated. Again, subtropical, because we're not like parts of Florida are tropical, other parts are subtropical. So not fully in fully tropical, like you see like islands in the Caribbean are, right? And you'll see different like plants, vegetation, things like that with that. Okay, let's move on then from that. Okay, we'll do the question later. What I want you guys to do now is go to page 3, and we're going to go to the top half of this sheet right here. Okay, and what I want you guys to do, let me see if I can fix this up. 4. Okay, so go ahead. I'm going to give you guys a few moments. Take a picture of that and copy that down to page 3. Copy that down to page 3. We're going to talk about factors that affect climate. That includes latitude and tilt. This is the top half of page 3, guys. Top half of page 3. Now, you didn't already hear, what is latitude? Latitude is how far you are from the equator. Again, these are not temperature numbers. These are latitude numbers. The closer you are to the equator, the lower the latitude. The farther you are from the equator, the higher the latitude, right? So with that being said, we have 3 climate zones. We kind of talked about it with our wind systems before, right? Okay, our 3 climate zones are going to be the tropics, which is right next to the equator. Tropics, we're kind of close to that. Then we have the temperate zone, which is kind of in between, in the middle there. Okay, again, make sure we're going to draw this on page 13. Going to draw this on, my bad. Going to draw this on page 3, actually. Going to draw it on page 3. And then we have the polar zones, which are the farthest from the equator at 90 degrees south and 90 degrees north latitude. Again, those are not temperature numbers. That's different. We're talking latitude. Okay, there are 3 subcategories of the temperate zone. We have dry, mild, and continental. We're in the mild part, by the way, here in most of Florida, Tampa Bay specifically. And also really important for us to draw, again, make sure for sure you got a picture, guys, to draw this now or later. Okay, we've got these arrows. These arrows down here represent the angle of the sunlight, okay? The sunlight is going to hit different parts of the earth differently. So in the tropic zone near the equator, it's going to make a direct hit. It's going to make a direct impact, kind of like a dart hitting a bullseye, right? Dart hitting a bullseye. That means the rays at that region are really strong and pack the most force. So it's like in a boxing match, when somebody takes a direct punch at the chest, that's what's happening at the tropic zone with the sun's rays. Makes it the hottest areas of the earth, okay? At these other parts of the temperate zone and the polar zone, we have lower angles, which means instead of it being a direct hit, it's going to kind of graze or kind of bounce off a little bit and not be as hot, not be as collected together. So temperate zone, we've got a 45-degree angle, and the polar zone, we have a 30-degree angle, okay? So those rays are not going to be as direct of a hit. which means that the areas are going to be cooler and not as hot. Okay, so kind of like in a boxing match, instead of taking a direct punch at the chest, it's going to be like when the boxer dodges and weaves and ducks, and they just take like a little sideways punch or kind of a missing punch at the shoulder a little bit. Okay, less impact and less force, which means less sunlight energy, less heat. Okay, and that's the Earth's surface right there, Earth's surface. So let's go ahead and make sure you got pictures of that. Let's check out our next video where we have Bill Nye explaining that for us as well. Let's check it out. We will have our first card question here in a minute. We are going to have our first card question here in a minute. Be ready to answer that in our chat for participation.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read.
Seasons. It's cold in the winter. Flowers bloom in the spring. We get lots of for the seasons. Why are the North and South Poles the coldest places on the Earth? Well, please consider the following. Let's say that this heat lamp is like the sun, because it's hot. And let's say that this globe is like the Earth, because it looks like the Earth. Anyway, we've mounted thermometers on the Earth like this. See? Now, the one at the equator is just about off the scale, and the one at the South Pole is right around the room temperature mark. And the ones in between are somewhere in between. That's because the heat is hitting the one at the equator almost straight on.
So it's a direct punch, right? Straight on, direct hit the equator, and then the farther out you go from the poles, the less direct hit those rays are going to be.
Whereas at the poles, it's just barely grazing by. And then somewhere in between, well, it's somewhere in between. You see, it's not that the equator is closer to the heat. It's that the heat is hitting it more straight on. See, if the Earth were sitting like this, then this thermometer would be the hottest, and this one would be the coldest. Anyway, that's why the very warmest places on the Earth are right around the equator, tropical rainforests and jungles. And the very coldest places are at the poles, because they're the ones that the energy from the heat lamp just barely grazes by. I mean, the energy from the sun. Well, anyway, thank you for joining me.
All right, so let's continue then with our first question of the day. Have your be ready to answer on the chat. Question number 1 for today. Please answer in the chat, everybody. So Lakia, Melissa, Michaela, Sanaya, Tatiana, Yorkies, Amira, Daniela, Diego, be ready to answer. Which of these climate zones has solar rays that hit the Earth at an angle of 90 degrees? What we just talked about. Is it A, tropics, B, temperate, C, continental, or D, polar? Please answer in the chat. Please answer in the chat. Practice quiz question. Practice test question. Hits at an angle of 90 degrees. Hits at an angle of 90 degrees. Need people to answer in the chat. Thank you, Sanaya. Great job. Okay, we got Michaela. Thank you. Tatiana, thank you. Thank you, Yorkies. Again, I need everyone answering questions in the chat. Our Lakia, thank you. First practice question of the day. Daniela, thank you. Got 10 seconds, guys. I still need more people. Still need more people. I think I need Melissa. Thank you, Daniela. Okay. I'm going to give shout outs to Lakia, Diego, Diego Perez, right? Tatiana and Sanaya, you got it correct. It is A, the tropics. The tropics is where we get the 90-degree angle, as we see right here in our notes. Right here, right, 90 degrees, tropics, tropics. All right, let's go ahead, finishing up for the day. Here is the second half of our notes on page 3. So go ahead, take a moment to take a picture of that or start writing that. I'll explain it here in a little bit. This is the end of our notes, guys, on page 3, bottom half of page 3. Quick water break. right, so let's go ahead and explain what we're looking at here. Okay. Oh, my bad. Let's skip. I got one more thing to show you guys. Hold on. Go ahead. We've got 2 video questions. My apologies. Number 1 on page 2 below your Go Blue, I want you to write down what causes the seasons. Why do we get winter, fall, spring, and summer? And number 2, how does Earth differ when North America is in summer versus winter? If you want to answer in the chat, you can, just as an early answer. But I'm going to go ahead and give you guys a moment to write those down on page 2. Take another little quick break for a moment, and then we'll begin our last video of the day. What causes Earth's seasons, and how does Earth differ when North America is in summer versus winter? See what you guys got here in a moment. See what the answer is here in a moment. All right. So let's go ahead, check it out, guys. Again, what causes Earth's seasons, and how does Earth differ when North America is in summer versus winter? I know we live here in Florida, but keep in mind, guys, we're in North America, not South America. That means we're in the northern hemisphere. We're in the top part of the planet. Again, South America, you're going to think about like Brazil. We've got Chile, Colombia, right? Venezuela, that's in South America, right? But let's go ahead and check that out in our other part of our video for Bill Nye. Again, what is the reason for the seasons?
The seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year.
Oh, number 1's coming up.
The reason we have seasons on Earth is because the Earth is tilted.
There we go, guys. Again, why do we get seasons? It's because of the Earth's tilt. The Earth's tilt, it's never sitting directly up. Mostly it's tilted one way or the other. That's what causes our seasons. Let's find out more.
Now let's say that this is the Earth. And there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime.
Okay. Number 2's coming up.
Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill, your shoe's untied.
Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons. Why are the north
All right,
and
so you heard it. The reason for the seasons is going to be Earth's tilt. So here in North America right now, it's winter, right? Earth's tilt are answer for number 1. So here in North America, it's winter, which means are we tilted away or towards the sun? We're tilted. It's very cold out. We're tilted away from the sun, guys. So summer, that is when the Earth is tilting towards the sun. Summer, and then winter is when the Earth is tilting away from the sun. Winter is when it's tilting away. Give you guys a moment for that. We're going to get to the last part of our notes for the day and finish up. So summer tilting towards the sun, winter tilting away from the sun. So let's go back to page 3 then, finish up our stuff for the day. I'm going to zoom in here. Okay. Oh, got to zoom out just a little bit. All right. So tilt is what's going to be causing the seasons. Does it tilt in the fall and the spring? Oh, a little bit. It's just slightly tilted or less tilted. We're going to see maybe an even tilt sometimes as well during fall and spring. Okay. If there was no tilt on, again, this is the bottom half of page 3, guys. Make sure we got a picture of this. Make sure we're getting this down. If there was no tilt on Earth at all, okay, that would be no seasons. Wouldn't be a good thing. Parts of it would be deserts, and a lot of parts would be frozen tundras. Again, the idea, if we increase Earth's tilt, the more increased the tilt is, the more extreme the seasons will be. So we'll see maybe colder winters versus warmer summers, et cetera, right? And the difference between the hemispheres increases. Again, don't forget, we're in the northern hemisphere. And then lastly, guys, make sure you draw that sun on the left. If you don't draw this sun, okay, the pictures don't make as much sense. Here we can see again, north is summer, south is winter. Again, the hemispheres, again, northern is North America, Europe, most of Asia, right? Whereas the southern hemisphere is South America, Australia, and Africa, right? So again, the seasons, if the north is in one season, the southern hemisphere is in the opposite season. Okay. There we have, again, winter, summer, and the other one there, and then fall and spring for kind of what's in the middle, what's kind of in between those two tilts, right? Everything in between. Okay. Make sure you guys got that. Again, I'm going to let you use the extra time of class to finish the notes. But let's go ahead. Let's do our last question of the day. Okay. So given what we learned today, last question, guys. During winter in Tampa, remember, Tampa, we are in the northern hemisphere, right? We're in the northern hemisphere. So if it's winter in Tampa, the southern hemisphere is tilted away from the sun. Winter in Tampa, the southern hemisphere is tilted away. Is that statement A, true, or B, false? Let's see, Amira, Daniela, Diego, Lakia, Melissa, Michaela, Sanaya, Tatiana, Yorkies, please answer in the chat. A or B? A or B? Answer in the chat. Thank you, Lakia. Last activity of the day. Okay, thank you, Sanaya. Thank you, Michaela. Thank you, Tatiana. Oh, thank you, Amira. Diego, solid. Okay, Melissa, oh, awesome. Love the participation, guys. Really good. That's good for our, again, participation grade at the end of the quarters. Keep in mind, guys, the quarter ends in a month. Again, I've kind of got the questions. Let's see the timing. Okay, I can see the time difference now. Shout outs to Sanaya, Tatiana, Diego. The answer is B, guys, because keep in mind, if the northern hemisphere is winter, that means the north is tilting away, which means the southern hemisphere is actually tilting towards. So good job there. Good job on that last